Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is a Probability and Statistics 2 for May-June 2021, and the code is 9709/62. Let's get started. So for question number 1, in a game, a ball is thrown and lands in one of the 4 slots labeled A, B, C, D. Now, Raju wishes to test whether the probability that the ball will land in slot A is 1/4. Now, A states suitable noun and alternative hypothesis for Raju's test. Okay, because here whether, so it means that H0, the P is 1/4 because of probability. But then it's mentioned whether or not it will land in slot A is 1/4. So that means we are not sure. Therefore, this is two-tail test. Now, the ball is thrown 100 times and it lands in slot A 15 times. So use a suitable approximating distribution to carry out the test at 2% significant level. So now your N is 100. The P is 1/4. So now our NP is 25, or I would say 100 times 1/4. That is 25. Okay, so 25 is greater than 5. And then the N is greater than 50. Therefore, now it will be approximated to normal distribution. So we have to calculate the variance, which is NPQ. So now the NP is already counted as 25. So when P is 1/4, that means your Q is 1 minus 1/4. That is 3/4. So you will be getting 18.75. Now here I will write X is binomial distributed with N 100, P 1/4. It has been approximated to normal. So I change the X into W. Then the mean is 25, variance is 18.75. Okay, now alpha is 2%. So alpha is 2%. Reject H0 if, now look at here. Okay, because this is two-tail test, look at here. This is two-tail test. Alright, two-tail test. So when two-tail test means that it will be two-tail test. Total is 0.02. So that means each tail is 0.01. So I will say reject H0 if the probability of Z less than Z is 0.01. Okay, so now you are considering 15 times lands in slot A. So therefore, Px less equals to 15. Okay, because I'm considering one side now. So now less equals to 15, that is the X. But then we have approximate the binomial into normal. Therefore, now we need to consider the continuity correction factor. Less equals to 15 means 15, 14, and so on. Right? And then now for the continuity correction factor, we can plus minus 0.5 from the given X value. That is either 15.5 or 14.5. But then it's mentioned less. So less means towards the left side. So obviously, when towards the left side, the interval that we need to choose must be 15.5 because we need to include the 3 ticks. So therefore, here I will write this is basically same as PW less than 15.5. And now I solve using this probability. Okay, so here is going to be PZ less than 15.5 minus 25 over square root of 18.75. And then here you will be getting PZ less than negative 2.194. So when less than negative 2.194, I draw another graph. Here is negative 2.194. Okay, and then now to get the probability, I will reflect to be positive. And then this will be the same probability. So now in order to get the orange region, that is total probability is 1 minus PZ less than 2.194. So here I will write this is PZ more than 2.194 and it is same as 1 minus PZ less than 2.194. And then that probability you can get it from from the table. That is going to be 0.9859, and then this is 0.0141. Now you compare with the alpha value. Our alpha value is 0.02. Okay, now look at here. Reject H naught if the probability is less than, not equal. Sorry, this is less than 0.01. Okay, so now we don't consider 0.02, but we consider 0.01 because we are considering the left tail, right? So then this 0.0141 is greater than 0.01. So go back to this criteria, the rejection criteria. We reject H naught when it is less, but then obviously now it's more. So I will just write down the decision. Since Px less equals to 15 is greater than 0.01, then you can just write do not reject H naught, or probably you can just write accept H naught, up to you. Okay, so when accept H naught means that now you have not enough evidence to conclude the H1, right? So I will just write there is insufficient evidence at alpha equals to 0.02 to insufficient evidence to conclude. The next one means that we have insufficient evidence to reject the probability of P equals to 1 over 4. So it's the same, right? So insufficient evidence to reject the probability of 1 over 4. Okay, so that's the conclusion of this hypothesis testing. Now question number 2. The variable x has distribution, binomial distributed, 400 and 0.01 probability, because this is n, here is p. Now find variance 4x plus 2. Okay, so for this case, your n is 400, your p is 0.01. That means now your q is going to be 1 minus 0.01, that is 0.99. Okay, from the binomial distribution. So basically the variance x, because your x is binomial distributed, so variance x is basically our NPQ. That is going to be 400 times 0.01 times 0.99. This is going to be 3.96. And then now we need to calculate variance of 4x plus 2. So our formula, variance of ax plus b, that is going to be a square variance x. That's it. Therefore, you will be getting 4 square variance x. That is going to be 16 times 3.96, and you will be getting 63.36, or probably you can just write 63.4. So it's up to you. Okay, because we need to round up to 3 significant figures for the final answer. B, first part, state an appropriate approximating distribution for x, giving the values of any parameters. Justify your choice. Okay, so now first of all, n is 400, which is greater than 50. Then the NP, so now 400 times 0.01. This is 4, which is less than 5. So when it is greater than 50 and less than 5, this one initially binomial. Okay, so now it will be Poisson distribution, Poisson approximation. Because for binomial, it can be normal approximation or Poisson approximation. So for normal approximation, it will be this condition. Okay, please take note. So, normal approximation to binomial. The n is greater than 50, then the NP is greater than 5. Okay, so when it is NP less than 5, therefore it's Poisson distributed, Poisson approximated. So here, this is Poisson approximation to binomial. That is, x will be PO, Poisson distributed, with mean 4. So that's the distribution for the x. Now part 2, use your approximating distribution to count this probability. So now I know that my x is Poisson distributed with mean 4, and now you need to calculate probability that x lies between 2 and 5. So just use the formula. X is Poisson distributed, lambda or mu, right? So the probability will be E minus lambda x over x factorial, or probably you can just write E minus mu. It's just different notation. So this is going to be px equals to 2 plus px equals to 3 until 5. And then you will notice that this exponential is constant. So I will write E negative 4. And then for the rest, just change accordingly. It will be 4 squared over 2 factorial because your x is 2. Then 4 cubed over 3 factorial plus 4 degree 4 over 4 factorial. Lastly, 4 degree 5 over 5 factorial. Then now from here, you will be getting 0.694. The value correct to 3 significant figures. Okay, next question, number 3. Now the random variable x takes values in the range x between 1 and p. That's why here, this will be your function. Where p is constant, the graph of the probability density function is shown in the diagram. Show that p equals to 2. Okay, you want to show this is 2. Alright, so we know that the area under the curve is basically the total probabilities, right? Area under the curve is the total probabilities, which is 1. That means now area of the curve, this is a triangle. So here is p minus 1 unit and this is p. Alright, so half times base times height, it will be 1. Now we need to show p is 2. So times 2 to the whole equation. I will get, okay, at the same time, this one just times. So I will get p squared minus p equals to 2. So rearrange it, p squared minus p minus 2 equals to 0. And now here, you factorize this. So when I factorize, to get p squared, it will be p times p. And then look at here. This is minus times with plus, it will be minus. So I will have 1 minus and 1 plus. And now I need to get minus p. So this 2 is 2 times 1. So in order to get minus p later on, it will be minus 2 and 1. So that when we multiply, this is minus 2p. Plus 1 times p, it will be plus p. Then now, when you multiply the first column, that is p squared, multiply the last column, that is minus 2p. That is minus 2, because minus 2 times 1. Then the middle column you plus. So minus 2p plus p is minus p. Okay, so you are getting the same quadratic equation. Now, for the factors, just cross multiply. Therefore, I will be getting p minus 2 times p plus 1 equals to 0. So one of them must be 0. Therefore, p minus 2 equals to 0, or p plus 1 equals to 0. So your p is 2, or p equals to minus 1. But obviously, your p is greater than 1. Okay, so therefore, this is not acceptable. Not accepted. Therefore, your p is 2. So shown. Okay, now you need to find EX, expected X, but then the function is not given. So we need to form the function. That means now P is 2. Okay, here is also 2. This is 2. So I will use 2 points to get the straight line because it's a straight line. So the first point with coordinates 1, 0. Second point is with coordinates 2, 2. Then now I need to find the gradient before I calculate the EX. So now the gradient m equals to y2 minus y1, 2 minus 0 over x2 minus x1. That is 2 over 1. This is my 2. So now my equation of the line, okay, y minus y1 equals to m bracket x minus x1. From the straight line first, because obviously from the graph, this is a straight line. This is a fx. So now I need to find out what is my fx right now. So I will use point 1, 0 for my x1 and y1. So my x1 is 1, my y1 is 0. That means y minus 0 is 2 times x minus 1. Therefore, my y is basically 2x minus 2. So from here, I will say that basically my fx is 2x minus 2 when the x is defined from 1 to 2. Okay, so 1 to 2. Otherwise, it will be 0. This will be your PDF, probability density function. So now to get the EX, I will just use the definition. This is integrate x fx dx from the limits 1 to 2. Because the x is defined from 1 to 2. So now here, I will just write integrate 1 to 2 x times 2x minus 2. Okay, so this is going to be integrate 1 to 2, 2x squared minus 2x. Now for integration, so integrate x degree n dx. This is going to be x degree n plus 1 over n plus 1 plus c, provided the n is not minus 1. Alright, so now this becomes 2x cubed over 3 minus 2x squared over 2. Then limits 1 to 2. And now replace the x by 2 first. So I will get 2 over 3, 2 cubed minus the 2 over 2 can be cancelled off. This is basically x squared. So you will get 2 squared. Then minus when the x is replaced by 1. So I will get 2 over 3, then minus 1. So then from here, you will be getting 5 over 3. That is your expected x. Okay, question number 4. When this journey to work consists of 3 parts: walking to the train station, riding on the train, and then walking to the office. The times in minutes for these 3 parts. Okay, this is for walking to the train. This is a train, and then this is another walking. Right. So now find the mean and variance for the total time for when this journey. So probably here I don't want to write walking. Here I write office. Office is F. So this is W. Okay, so now your T, so mean and variance for the total time. So then I will just write expected total T. Okay, since this is T, that means the train I write probably R. Alright, so it will be 15.0 plus 32.0, get all the mean. So it will be 8.6. Then you will be getting 55.6. T means total time. Then the variance time, total time, it will be just add on all the variances. And then you will be getting 14.9. Okay, now B, if Wendy's journey takes more than 60 minutes, she is late for work. Find the probability that on a chosen day, Wendy will be late for work. So from here, I know that the total time is normally distributed with mean 55.6, variance is 14.9. When the total journey takes more than 60 minutes, then she will be late. Now you need to count probability that she will be late. So it means PT more than 60. So now, when you are given the normal distribution, we need to standardize it before we get the probability using this formula. Therefore, it will be PZ more than 60 minus 55.6 over square root of 14.9. Then here is going to be PZ more than negative 1.104. Positive, sorry, it is positive because 60 minus 55.6 is positive. So when more than positive value, now I sketch a graph. That is going to be 1.104, and this is greater than means the region towards right side. So the region towards right side is basically 1 minus all previous regions. So I will write 1 minus B Z less than 1.104. And the probability can be found using the table. That is 1 minus 0.8729. Then you will be getting 0.1271 and round up to 3 significant figures, that will be 0.127. Okay, so that is the solution of part B. Now find the probability that the mean of journeys over 15 chosen days will be less than 54.5. Now is the mean journeys time. Okay, so it means that now your mean of the total time, that is same distribution, but the variance is instead of now 14.9, now you have to divide by 15 days because of the mean. And then you need to calculate that the probability is less than 54.5. Right, so now again, standardize it since it is normally distributed. So less than 54.5 minus 55.6 over square root of 14.9 over 15. And this is going to be PZ less than negative 1.104. Okay, I go back to the previous question. I think I wrote wrongly. This is not 1.104, it is 1.140. Okay, so mistake. I overlook the value. Alright. And now this is 1.14104. So this is negative value. Sketch a graph. Less than negative 1.104, that means the region towards left side. And now here, the negative value will be reflected to be positive. And then the region will be the orange color. So obviously, this is total probability is 1 minus less than the positive value. So this is going to be 1 minus P, or probably I just write this is same as P Z more than 1.104, and it is 1 minus PZ less than 1.104. Then now here 1 minus. So this property can be found from the table. It's 0.8651. Okay, let me check. Okay, correct. Then here is going to be 0.1349 and round up to 3 significant figures, that is 0.135. So that's all for the solution of this question. Question 5. The time in minutes spent by customers at a particular gym has distribution. In the past, the meal has been 42.4. Following the installation of some equipment, the management wishes to test whether the mu has changed. Okay, now A, state what is meant by type 1 error in this context. So let me write down the definition of type 1 probability first. The type 1 probability is basically probability of rejecting H0 given that H0 is true. Okay, this is the definition for type 1 error. So now your H0 is basically mu equals to 42.4. Your H1 has been changed. That means it's two-tailed test. Mu is not equal to 42.4. Now, if you need to explain the type 1 error in this context, that means the type 1 error means the population mean, this is the time, okay, population mean time. Now we need to say that reject H0. So when you reject H0 means that it is no longer 42.4. Alright, so it means that it has changed. So has changed because of reject H0. Although, okay, but then given that H0 is true, although mu has not changed. Although the population mean time has not changed. Okay, the mu is still 42.4. Alright, so that is the meaning of this type 1 error. Now B, the mean time for the sample of 20 customers is found to be 45.6 minutes. Test at 2.5% significant level whether the mu has changed. Okay, so for this case, I will write H0 mu equals to 42.4. H1, the alternative hypothesis, mu is no longer 42.4. Then the alpha is 2.5%, that means it's 0.025. Okay, so now when we look at the question, it's mentioned that it is normally distributed and the variance is given, right? So since it is mentioned normally distributed, means that for this hypothesis testing, we will be solving using normal distribution. So now, before I write down my rejection criteria, I need to sketch a graph. Now, it's mentioned not equals to means two-tailed test. So the total probabilities here for these two parts, it will be 0.025. Now, each part, it will be 0.025 divided by 2. That is 0.0125. So now, when the region is, each part is 0.0125, that means now the total regions towards left side will be 1 minus 0.0125. That is going to be 0.9875. So now I have to read the table, the normal table. When the total probabilities is 0.9875, then the critical region is basically 2.24. The critical value is 2.24. Therefore, I'm writing now reject H0 if the Z, right, both sides is greater than 2.24. So that's why I put modulus. Supposedly this is negative 2.24 because it's two-tailed test. Now, our calculation is Z equals to X bar minus mu over sigma over square root n. So this is going to be, now X bar is given. Okay, 20 customers, it will be 45.6. That is the mean for the 20 customers. That is our X bar. So 45.6 minus the mean. Mean is the mu at the H0. That is 42.4. Over standard deviation over square root n. So now you are given variance. This is basically sigma squared. So to get the sigma, I will just take the square root of this. So I will direct combine. You can write sigma over square root n, or probably you can write square root of sigma squared over n. So here I will write square root of 38.2 over the n is 20. Then here you will be getting 2.315, and now 3 significant figures, this is going to be 2.32. So now you check. 2.32 is basically inside the region because the line is 2.24. Alright, therefore the decision is region H0. So I will write down the decision and conclusion over here. So you write, since the z is greater than 2.24, therefore we reject H0. This is the decision. So when region H0 go back to your H0, that means it has been changed, right? Sufficient evidence to say that the mean time has changed. So that is sufficient evidence at alpha equals to 0.025 to conclude that the mean time has changed. The population mean time. Okay. We can go back to the previous question. The mu, you can just write that mu has changed, or mean time has changed. Okay, so that's the conclusion of this hypothesis testing. Question 6. The height h centimeters of a random sample of 100 fully grown animals of a certain species were measured. The results are summarized as follows. A. Find unbiased estimates for population mean and variance. So basically, this is a population mean. So the unbiased, the estimates will be hat, right? Mu hat is basically h bar. H bar is summation h over n. That is going to be 7570 over 100. Then you will be getting 75.7. Now, the unbiased estimates for the variance, this is, okay, I will write like this. This is sigma h squared hat. Right, population variance is sigma square. Then this is same as s square h because we estimate it using sample. So then this is going to be 1 over n minus 1 summation times by summation h squared minus square of summation h then over n. This is the formula for unbiased estimates. So your n is 100. So 1 over 100 minus 1, that is 99. Summation h squared, just copy 588050 minus 7570 square it over 100. Right? Then from here, you will be getting 151.525. So when you round up to 3 significant figures, that is going to be 152. Okay, done for first part. Part B, calculate a 99% confidence interval for the mean height of animals of this species. So 99% confidence interval for mean height. That is going to be mean height. Okay, so here I will write like mu h. I will write mu h. Right, mu h. So this mu h is basically the mu over here. This is mu h. So this can be found using h bar plus minus. Okay, now you can just check this value. The confidence interval is 99%. That means in between is 0.99. Alright, then here or this side, it will be 0.01 divided by 2. Because total of these two left and right side is 0.01. So that the total probability is 1. And this is 0.005. So therefore, if you want to write down the general formula, this is going to be Z 0.005. Okay? Because in the question, the n is 100. Therefore, we will be using the Z, even though the population is not given. Because of the central limits theorem, the n is large, so it will be approximated to normal distribution. So here, then I will write square root of S square H over N. This is the formula. So the H bar already counted just now. H bar, I will use 75.7. So 75.7. And this critical value, that means it's over here. You just read the table. The normal table, the total regions is going to be 0.995 because you add up these two values. And the value, the critical value, it will be 2.576. So therefore here 2.576, which means this blue line is negative 2.576. Okay, then square root of the SH squared, I will use the original value, which is this 151.525 for more accurate calculation. And then the n is 100. So here you will be getting, when you calculate using minus, you will be getting 72.5, and then when you calculate using plus, that is 78.9. Okay, therefore this is your 99% confidence interval for the mu. Now 4 random samples were taken 4 random samples, and 99% confidence interval for population mu was found from each sample. Part C, find the probability that all 4 of this confidence interval contain the true value of mu. Okay, so now go back to the previous. This 99% confidence interval for mean, that means probability of the interval, so that the probability that the interval that will contain the true mean, okay, true population mean is 99%. So from here, right, all 4 intervals contain the true mean. That means P containing true mean, true mu, equals to 0.99. That's the meaning of the 99% confidence interval. So now you are taking 4 samples and all 4 contain that true mean. So now probability of all 4 confidence interval contain true mu. That is going to be 0.99 to the power of 4, because you are considering all 4 now. That is going to be 0.9606, and I round up to 3 significant figures, that is 0.961. Okay, question 7. Customers arrive at a particular shop at random times. It has been found that the mean number of customers who arrive during 5 minutes interval is 2.1. Okay, so this is the time interval. Therefore, this must be Poisson distributed. Okay, now A, find the probability that exactly 4 customers arrive during a 10 minutes interval. So 5 minutes is 2.1. Alright, so 5 minutes is 2.1. That means now 10 minutes, it will be 2.1 times 2. That is 4.2. That is our lambda. Okay, that means now your x is Poisson distributed with lambda or mu 4.2. Now, exactly 4. So Px equals to 4. So now again, for Poisson distributed or Poisson distribution, you can write lambda or mu for the mean. So P, the probability is counted using E minus lambda x over x factorial, or E minus mu, up to you. So then from here, it will be E minus 4.2, 4.2 degree 4 because of x equals to 4, then over 4 factorial. So this is going to be 0.194. Part B, find the probability that at least 4 customers arrive in 20 minutes interval. Okay, just now, 10 minutes, 4.2, right? So now, 20 minutes, so I will write 5 minutes. It will be just now 2.1. Okay, 5 minutes, 2.1. So now 20 minutes, it will be 2.1 times 4. Then you will get 8.4. And now here I will write x is Poisson distributed with mean 8.4. Okay, at least 4. At least 4 means 4 onwards. So for Poisson distribution, our x values start from 0. Then until infinity. So now, from here, at least 4. At least 4 means it will be 4, 5, 6, and so on. So I will write down 4 first. Right, all this. That means I can use total probabilities 1 minus all previous. That is how I count the parts B later on. So this is going to be 1 minus P x up to 3. Okay, so Px up to 3 means start from 0, then until 3. And then use back the same formula. Since the E minus lambda is in common, because this one does not depend on x, so I will write E minus 8.4. Then, now when x equals to 0, when you look at the formula here, lambda power x, it will be, lambda power 0 will be 1, 0 factorial is 1. So the first term is always 1. Then plus 8.4, degree 1 over 1 factorial, no need to write. Then plus 8.4 squared over 2 factorial plus 8.4 cubed over 3 factorial. Then from here, you will be getting 1 minus 0.03226. So lastly, it will be 0.968. Okay, now, next part, use a suitable approximating distribution to find the probability that fewer than 40 customers arrive during a 2-hour interval. Okay, so when 2-hour interval, and now you are given 5 minutes. So now I need to get 2 hours means 120 minutes. 2 hours means 120 minutes. Okay, so now my lambda becomes 120 divided by 5 because you are given every 5. So every 5, you will be getting 2.1. So you divide by 5 and times 2.1. That is going to be 50.4. So since your lambda is large, right? So therefore, our approximation, initially it was Poisson. So now we have to approximate to normal. Because your n is greater, your lambda is greater than 15 now. So it means that now x was Poisson distributed with 50, it will be 2.1. Okay, your lambda is 50.4. Then now it becomes normally distributed. The mean is 50.4 and then the variance is 50.4 as well. Okay, initially your x for I would say x is Poisson 50.4. I will write x, okay, x is Poisson distributed. The mean supposed to be 2.1, the NP, so it should be, I should write 50.4 then. Okay, then from here it has been changed to normal, right? So then I will write p x less than 40. So here less than 40. Remember, Poisson is discrete. Okay, this is discrete. Normal is continuous. Therefore, the continuity correction is needed here. So then fewer than 40. So less than 40 means it is up to 39. And now we are allowed to plus minus 0.5 from 40. Therefore, I will write this is PW less than. So less than means obviously I will choose less than 39.5 to include the 39. So then you standardize it. So when you standardize, it will be 39.5 minus 50.4. That is a mean over the standard deviation. So square root of the variance to get standard deviation. Then now here is going to be PZ less than, the value is negative 1.535. So now you sketch the graph. Okay, it is symmetrical graph. So negative 1.535 and less than, that means this is a region. Now this can be reflected to positive 1.535 and the region will be the red color. So the red color region, it is PZ more than 1.535. Okay, so the red color is basically the whole probability, which is positive 1 minus the previous probability. This is 1 minus PZ less than 1.535. That is the working for this calculation. And now get the probability from the table. That is going to be 1 minus 0.9376, and at last you will be getting 0.0624. So this is the probability correct to 3 significant figures. Alright, so I have completed this whole paper and comes to the end of the video. Thanks for watching. Please subscribe to the channel if you enjoy watching my video, and share this channel with your friends. And also stay tuned for more upcoming videos. Thank you everyone. Bye.